We're talking about free fall today, and during free fall an object is only under the influence of gravity. There are no other forms of propulsion and not air resistance included either. So we're not talking about rockets, we're not talking about anything with an engine moving through the air like an airplane. We're also not talking about pieces of paper moving through the air. Instead, we're talking about things like baseballs and footballs, anything moving through the air where air resistance is negligible. Of course, air resistance is always present. We're just saying that it's not very noticeable in this case. We're also saying that there's no engine attached to the object. Only gravity is making it move differently. Objects that are undergoing free fall all have the same acceleration. So if we neglect air resistance, all objects fall downward at an acceleration of negative 9.81 meters per second squared. What this means is that their acceleration is their velocity is decreasing by 9.81 meters per second every second. And so we can see that in the visual over to the left, that if we start at 0 meters per second, after 1 second, our velocity has gone down by 9.81 meters per second. Now the down just means, the negative just means it's moving downward in this case. After 2 seconds, it's gone down by 9.81 meters per second more. So now it's 19.62 downward. After 3 seconds, we've again gone down by 9.81 meters per second to be at negative 29.43. And after 4, we're at negative 39.24 meters per second. But what if an object is thrown upward? What happens differently? So again, our acceleration is negative 9.81 meters per second every second. Now for this visual here, we've simply rounded that off to negative 10 meters per second. So it's just rounded off to make the numbers nice. So if at time 0 we start at 30 meters per second, after 1 second our velocity has gone down by 10 meters per second, and we're now at 20. After another second, our velocity has gone down by 10 more, so now we're at 10. And after another second, our velocity has gone down 10 more, and so now we're at 0, which means that the velocity at the top is momentarily 0 before it starts to change again. After another second, we are now decreased 10 more, so now we're at negative 10 meters per second, which means we're going downward at 10 meters per second instead of like at 2 seconds where we're going upward at 10 meters per second. After 5 seconds, we've decreased 10 more to go negative 20, and after 6 seconds, we've decreased 10 more to be at negative 30, and so forth. And what we see here is that equal elevations, our velocities are equal in magnitude, meaning they have the same value, 30, but they are opposite direction, meaning one is positive and one is negative. So if ever we start and stop at the same elevation, we can first of all say our displacement is 0 because we have not changed our height. But we can also say that the final velocity is simply opposite that of the initial. So if the initial is 30, we automatically know the final is negative 30.